Space, it's the final frontier. It's a vast, uncharted territory that has fascinated humanity for centuries. For centuries, humans have gazed at the stars and dreamt of exploring the cosmos. But there's a problem. The distances involved are almost incomprehensible. Space is really, really far away. Even the closest celestial bodies are millions of miles from Earth. To get there, we need a powerful force, something that can break free from Earth's gravity and propel us into the void. This is where rocket propulsion comes into play. That force is rocket propulsion. It's the technology that allows us to overcome the immense gravitational pull of our planet. Rocket propulsion is the heart of space exploration. Without it, our dreams of reaching other planets and stars would remain just that, dreams. It's the engine that drives our rockets, satellites, and probes across the vast distances of space. It enables us to send missions to Mars, explore the outer planets, and even venture beyond our solar system. Without it, we'd be stuck on Earth, forever bound by our planet's gravity. Our ability to explore, to learn, and to expand our horizons would be severely limited. But with rocket propulsion, we can reach for the stars. We can send astronauts to the moon, rovers to Mars, and probes to the farthest reaches of our solar system. Think of it like this. Imagine throwing a ball. The harder you throw, the farther it goes, right? But there's more to it than just strength. The harder you throw, the farther it goes, right? But in space, you also need to consider direction, speed, and timing. Rocket propulsion is like that, but on a much grander scale. It's about generating enough thrust to escape Earth's gravity and travel vast distances. By harnessing the power of controlled explosions, we can create enough thrust to launch spacecraft into orbit and beyond. These controlled explosions are meticulously calculated to ensure maximum efficiency and safety. Rocket propulsion is not just about raw power, though. It's also about precision and control. The ability to fine-tune a spacecraft's trajectory is crucial for successful missions. It's also about precision and control. We need to be able to steer our spacecraft, adjust their trajectory, and slow them down when they reach their destination. This requires a deep understanding of physics and engineering. We need to be able to steer our spacecraft, adjust their trajectory, and slow them down when they reach their destination. This involves complex calculations and precise maneuvers. This requires sophisticated engines and a deep understanding of physics. Engineers and scientists work tirelessly to improve rocket propulsion systems, making them more efficient and reliable. The story of rocket propulsion begins long before the first satellite or astronaut. It is a tale that stretches back through the annals of history, to a time when the concept of space travel was but a dream in the minds of a few visionary individuals. It starts with a simple invention, gunpowder. This seemingly humble mixture of saltpeter, sulfur, and charcoal would become the catalyst for a revolution in propulsion technology. Invented in ancient China, gunpowder was initially used for fireworks and weapons. The Chinese were the first to harness its explosive power, creating spectacular displays in the night sky and formidable weapons of war. But some people saw its potential for something more: space travel. The idea that this explosive force could propel objects beyond the confines of Earth began to take root in the imaginations of early thinkers. One of the earliest visionaries was a Chinese official named Wan Hu. His story, though shrouded in legend, is a testament to the enduring human desire to reach for the stars. Legend has it that in the 16th century, Wan Hu attempted to launch himself into space using a chair strapped with 47 rockets. Though the outcome of his experiment is lost to history, the tale of Wan Hu captures the spirit of innovation and daring that has driven humanity's quest for space. While the story is likely apocryphal, it highlights humanity's early fascination with rocketry. This fascination would only grow stronger over the centuries as new minds took up the challenge of reaching beyond our world. Fast forward a few centuries and we meet pioneers like Konstantin Tsiolkovsky and Robert Goddard. These men, driven by curiosity and a relentless pursuit of knowledge, would lay the groundwork for modern rocketry. Tsiolkovsky, a Russian scientist, was one of the first to develop the mathematical framework for rocketry. His equations and theories provided a scientific basis for the principles of rocket propulsion. He calculated the speed needed to escape Earth's gravity and envisioned multi-stage rockets, concepts that would later become essential for space exploration. Tsiolkovsky's work was revolutionary, laying the theoretical foundation for the rockets that would one day carry humans to the moon and beyond. Meanwhile, Goddard, an American physicist, took those theories and put them into practice. His experiments with liquid-fueled rockets marked a significant leap forward in the field of rocketry. In 1926, he launched the world's first liquid-fueled rocket. This was a major breakthrough, as liquid fuels offered more power and control than solid fuels. Goddard's work demonstrated the practical viability of Tsiolkovsky's theories. This was a major breakthrough, as liquid fuels offered more power and control than solid fuels. The ability to fine-tune the thrust and direction of rockets opened up new possibilities for space travel. These early pioneers, driven by a thirst for knowledge and a passion for exploration, laid the foundation for the future of rocketry. Their work was not just about reaching the stars, but about understanding the fundamental principles that govern our universe. They dared to dream of a future where humanity would break free from Earth's gravity and venture into the cosmos. Their dreams and innovations have paved the way for the incredible advancements in space exploration that we witness today. Rockets might seem complicated, but the basic principle behind them is surprisingly simple. At their core, rockets are just machines designed to move something from one place to another, often from the ground to space. This journey, however, requires overcoming Earth's gravity, which is no small feat. It all boils down to one of the fundamental laws of physics, Newton's third law of motion. This law is a cornerstone of classical mechanics and is crucial for understanding how rockets work. This law states that for every action, there is an equal and opposite reaction. It's a principle that we can observe in many everyday situations, not just in the realm of rocket science. In simpler terms, this means that when you push something, it pushes back on you with the same amount of force. This is why, for example, when you push against a wall, the wall pushes back with an equal force, even though it doesn't move. Imagine standing on a skateboard and throwing a heavy ball forward. This scenario is a perfect illustration of Newton's third law in action. As you throw the ball, you'll notice that you and the skateboard move backward. The force you exert on the ball to throw it forward is matched by an equal and opposite force that pushes you and the skateboard backward. That's Newton's third law in action. It's a simple yet powerful concept that explains a lot about how forces work in our world. Rockets work in a similar way. They rely on the same principle to propel themselves into space. They expel hot gas out of their nozzles at high speed. This is the action. The gas is forced out of the rocket, creating a powerful stream. The reaction is the force that propels the rocket in the opposite direction. This force is what lifts the rocket off the ground and into the sky. The faster and heavier the gas expelled, the stronger the thrust and the faster the rocket accelerates. Think of a balloon. When you blow air into a balloon and let it go, the air rushes out the back, propelling the balloon forward. When you blow air into a balloon and let it go, the air rushes out the back, propelling the balloon forward. This simple experiment is a great way to visualize the basic principle of rocket propulsion. Rockets work on the same principle, but instead of air, they use a carefully controlled mixture of fuel and oxidizer that burns to produce hot gas. This combustion process is highly efficient and generates a tremendous amount of energy. This process of burning fuel and expelling gas creates thrust, which is the force that overcomes gravity and propels the rocket upward. The thrust must be powerful enough to counteract the gravitational pull of the Earth. The amount of thrust needed depends on the weight of the rocket and its payload, as well as the destination and the speed required to get there. Engineers meticulously calculate these factors to ensure a successful launch and mission. The journey to the stars is a complex dance of physics, engineering, and human ingenuity.